Hi everybody, today we're going to talk about the unit circle approach to trig values. As we talk, you'll see there's a big connection between triangles and how we did trig values previously and how we're going to look at them today. So let's start by looking at a unit circle. A unit circle is a circle with a radius of 1. We can put any point P on the circle and it's going to have coordinates x, y. Today we're going to keep all of these points in the first quadrant. It's important to see that P is the point on the circle that corresponds to an arc length of t. Adding a dotted vertical line from the point P to the x-axis gives us a triangle where t is our reference angle. The radius r being equal to 1 is the hypotenuse of the triangle. The opposite side will be the distance up, which is y. The adjacent side will be our horizontal distance over, which is x. Let's take a look at finding sine of t, cosine of t, and tangent of t. Sine of t will be the opposite, which is y, over the hypotenuse, which is 1. Cosine of t will be the adjacent x over the hypotenuse, which is 1. Tangent will be the opposite y over the adjacent x. It will be important to add these three formulas to your notes. Make sure that you write that this is for a unit circle. The formulas will change when the value of r changes. Let's practice by finding the values of the trig functions at the point the square root of 3 over 2, 1/2. If it helps, you can estimate the point on the circle and then draw a triangle in to help you find the sine, cosine, and tangent. You know the radius is 1, so that will be our hypotenuse. We know the opposite is 1/2, and we know the adjacent is the square root of 3 over 2. Sine of t will be the opposite, 1/2, divided by 1, which is 1/2. Cosine will be the adjacent, square root of 3 over 2, divided by 1, which is the square root of 3 over 2. The tangent is the opposite over the adjacent, but it's also helpful to remember that tangent is sine t over cosine of t. This means I have 1/2 divided by the square root of 3 over 2. When we divide by fractions, we remember to flip the second fraction and change it to multiplication. The 2's will cancel, which leaves me with 1 over the square root of 3. We don't like to have radicals in the denominator, so I'm going to multiply by the square root of 3 over the square root of 3. In the numerator now, I have the square root of 3, and the denominator, I have 3. As you're putting in answers into your homework, quiz, or other assignments, make sure that you pay attention to the instructions. When the instructions say to put exact values, that means that you leave the radicals. So you would want to enter as the square root of 3 over 3 and not put this in your calculator to get a decimal. Some problems may allow you to use decimals. In that case, you can grab your calculator. But when it says exact, it means put in fractions and leave the radicals alone. Find the exact values of the three trig functions 0, pi over 2, pi, and 3 pi over 2. So we're going to stay with our unit circle, and I'm going to draw a circle on this graph. Starting at 0, our point is 1, 0. Remember that the first coordinate is cosine, and the second coordinate is sine. This shows us that sine of 0 is equal to 0. Cosine of 0 is equal to 1. Tangent, remember that we can use sine over cosine, 0 over 1 is just 0. If we move to pi over 2, I have the point 0, 1. This says the sine of pi over 2, which is the y-coordinate, is 1. Cosine of pi over 2, which is our x-coordinate, is 0. Tangent of pi over 2 would be 1 over 0, which is undefined. If I go over to pi, I see the point -1, 0. Sine of pi will be 0. Cosine of pi will be -1. Tangent of pi, 0 over -1, is 0 again. Our last point, 3 pi over 2, is the point 0, -1. Sine of 3 pi over 2 will be -1. Cosine of 3 pi over 2 is 0, which tells us the tangent of 3 pi over 2, -1 over 0, is undefined. What's nice about being able to draw this is you can always come back to the drawing and not have to memorize all of these values. If I'm given sine of negative pi, I can draw a coordinate system. Negative pi says go underneath the x-axis and stop at the point -1, 0. Sine says look at the y-coordinate, which tells me that sine of negative pi is 0. Cosine of 3 pi, I also draw the xy coordinate system. One full circle would be 2 pi. I go one more half circle around, which takes me to 3 pi. I'm again at the point -1, 0, but this time I'm looking at the x-coordinate, which says cosine of 3 pi is -1. Let's look at what happens when we don't have a unit circle, which means r is not equal to 1. We can again draw back on our knowledge about right triangle trigonometry to find the values of sine, cosine, and tangent. When I look at sine of t, it would be equal to the opposite y over the hypotenuse r. Cosine of t would be the adjacent, which is x, over the hypotenuse r. Tangent is the opposite y over the adjacent x. Notice that it does not have r in its calculation. Let's find the values of the trig functions at the point 512. To help us visualize that, I've included a circle with the point 512. I add a dashed line for the radius, and I add a dashed line down to the x-axis. Let's label it to get started. The opposite is the vertical height, which is 12. The adjacent is equal to 5. Notice that I don't know the radius. To get the radius, I'll use the Pythagorean theorem that says 5 squared plus 12 squared will be r squared. 5 squared is 25. 12 squared is 144. That's equal to r squared. 25 plus 144 is 169. If I take the square root of 169 and I take the square root of r squared, that tells me that 13 is equal to r. Sine will be the opposite, 12, over the radius of 13. Cosine will be the adjacent 5 over our radius of 13. Lastly, tangent will be the opposite 12 over the adjacent 5. In the next video, we'll move the point to other quadrants on our xy coordinate plane. To find the trig values in other quadrants, we'll introduce reference angles, and we'll pay close attention to the sign of our solutions.